Now let us see a few real world example of the protection layers. So let us take the example of refinery. We have the pressure relief valve PRV in the install. So case is in a crude distillation unit, a blocked outlet caused rapid pressure buildup. So the PRV lifted and safety vented hydrocarbons to flare. That is the basic design intention. So outcome prevented vessel rupture. So basically suppose PRV is there. So actual case is that there is a crude distillation unit, and in case of high temperature pressure increase, to handle this scenario, when PSV is installed and which is connected to flare, right? So PSV installed on the distillation unit is connected to flare, means whatever release is there, that will be burned. So in this case, when there is a high pressure, PRV will be lifted and release will be diverted to the flare. So here is basically a type of this IPL is a mechanical safeguard as per this reference is API 520-521. So PSV connected to the flare installed on the distillation unit. In case of high pressure release, this PSV will be pop up, release to the flare. So this is a basic design of the IPL in the this crude distillation unit. That's one example. Second example, one chemical plant, there is a high temperature reactor trip. So case is exothermic polymerization reactor risk runaway due to the cooling failure, right? If there is a cooling water supply going on, in our first case, if you consider the steam supply instead of that cooling water supply, that is also we can consider there. So let us take the cooling water supply. In case of steam supply, that is required for the initial heating, then there is a reaction, and it's an exothermic reaction. So in case of the present our example, let us have the cooling water supply for the cooling in the exothermic reaction. If cooling water supply fails, so what happens? So a safety instrumented function like SEAL 1 or SEAL 2 trip the reactor. So here in this case, temperature, because of cooling water supply failure, temperature increase, pressure increase, and there is a temperature transmitter, pressure transmitter that will close the feed, can start the alternate cooling water supply. Both can be there. So outcome is prevented runaway reaction because of there is a starting of another cooling water supply loop, or closing the feed flow and stopping the reaction. So both outcome is preventing the runaway reaction and toxic release. So this is instrumented safeguard. Type of IPL is instrumented safeguard, and reference is IC 61511. So that's another example of this IPL. The next example of IPL, let us take the fertilizer plant nitrogen purging system. That is a case study. So ammonia storage tank risks explosion due to the oxygen ingress. So there is one reaction. So basically there just to prevent the explosion, nitrogen purging is required. So there is a continuous nitrogen blanketing system maintained in the atmosphere. So in case basically a basic example is there that during the, it's a by mistake storage is mentioned, but during the reaction there is a possibility of explosion due to the oxygen ingress. So basic here prevention is that inertization is carried out, contains nitrogen blanketing system maintained to maintain the inert atmosphere. So outcome is preventive explosive atmosphere formation prevented through the inert safer design by purging the nitrogen system. So this is inert safer design safeguard. So in any explosive atmosphere, normally when we maintain the nitrogen inertization or blanketing, so that is a basic inert safer design safeguard or protection layer that we can use in the process. Then gas processing, gas detector with auto shutdown case means if there is a release, so gas will detect and either that will close the feed to the system or reactor or reaction, and this way that can be mitigated the effects of this hazard. So in a compressor station, another example, in a compressor station, a methane leak occurred. So if there is a methane leak occurred, a detector will detect it, shut down, will be activated to stop the compressor. So outcome prevented fire or explosion escalation because there is a release. Normally release is always early detection. So there is a basic fundamental principles to give the shutdown to the compressor. Suppose there is a methane gas leakage or H2S gas leakage. In that case, what happens? Normally In case of fire or explosion, there is a concept lower flammability limit or lower explosive limit. So early detection says suppose there is a LEL 100 ppm. So your shutdown should activate based on 25% of LEL or 50%. There are different guidelines available. International guidelines are available. We can refer that guideline and we can stop in our case, we can stop the compressor in the early stages of the leakage. So early stages, 25%, 10% also can be defined based on the company philosophy or standards we refer. So 25-50% of LEL that detect the detection these are gas detectors, and that will stop the compressor. So this is basically early detection leak detection system that is used. So IPL type with detection instrumented safeguard. Of course, effectiveness in case of IPL, in case of safeguard, if we as per our earlier example that we have the 4 detectors installed in the 100 meter square area, we can consider safeguard here. But in case of protection layer, gas mapping study is must for the gas detector. So if there is no gas mapping study, so we can take detector system as a safeguard. So very basic in gas detection system. So fire gas mapping should be considered, should be done to consider this as a protection layer. So that's a basic difference between the detector as a safeguard and protection layer. By any other means also you can confirm if there is any other procedure that you can confirm that 100% coverage is ensured by installation of detector, then of course you can consider, because in 2D layout we can just do the mapping by drawing just marking the circles on the detectors area coverage, and we can check accordingly. But normally critical case is 3D. In case of 3D, fire and gas mapping is must, because in case of 2D we can draw the drawings, but in case of 3D we have to consider horizontal vertical leakage also, and escape of gases also, release of gases and dispersion of gases. So in that case FNG mapping is must. Okay, now there is a basic difference between this safeguard and IPL. So quickly we'll do it and we'll just close for the question answer. So basically this all I am summarizing the difference between safeguard and IPL. Already discussed that in case of safeguard, any measure, design, device, system or action that prevent, controls or mitigate the hazard. But in case of IPL, a special type of safeguard that is independent, reliable and auditable, providing measurable risk reduction. So that is a protection layer. Independent, in case of independence, safeguard may or may not be independent from the cause and control, right? Control means your control system. In case of IPL, must be independent of initiating cause and other IPLs. So independent, protection layer should be independent from initiating cause also and from the IPLs also, protection layers also. Reliability varies. For PP, less reliable than engineered system. PP, administrative controls are less reliable, trainings less reliable. In case of IPL, quantifiable reliability, risk reduction factors method should be used, and that should be the standard one available from the reference standard. Auditability, of course, not always tested or verifiable. Example, training, not always tested. In case of training, as I discussed, all complete system is available, then only tested and reliable. So in case of IPL, of course, must training system must be designed and implemented. So must be testable, inspectable and verifiable. In case of training, as I said that during the classroom training, 75% of people should achieve 75% or more marks. So that is, we can say it's a quantifiable. So example of safeguard: PP, training, SOP, alarm, relief valve, interlocks. For IPL, relief valve, SIS, SIF, independent alarms for operator action, containment like dikes, fire gas detection with auto shutdown and all these things, right? So these are the basic difference. So high pressure, example scenario: high pressure in the reactor to deviation, more pressure in the reactor due to the cooling failure. So safeguarding has a pressure control loop, high pressure alarm, pressure relief valve, emergency venting procedure. So in case of IPL, PSV, yes, we can consider. We are just comparing safeguard with the IPL. So in case of safeguard, pressure control loop, yes, it can be considered. PSV, it can be considered. Operator response to alarm, of course, if response time is less than the event happened, then we can consider. SOP may not be. So we should not consider in case of emergency venting, right? So this is the basic. There are a few other examples also. You can refer later on. I will share the presentation.